Hi everyone, my name is Gill Braulik. I'm a research fellow at the University of St Andrews, and I'm going to be talking today about acoustic monitoring of fishing with explosives. I'm going to outline 3 different studies that have used acoustics in different forms to document blast fishing in Tanzania, and we'll finish with a comparison of the advantages and disadvantages of each of these different approaches. I want to acknowledge my co-authors, Jason Rubens, who is a marine manager based in Dar es Salaam, who's one of the founders of the Tanzanian Blast Monitoring Network and has been working on blast fishing for around 15 years, and Jamie McCauley, who's now based at Aarhus University in Denmark, who was heavily involved with lots of the technical aspects of the underwater acoustics and the analysis. Fishing using explosives is a quick and easy way to quickly harvest large amounts of fish. And despite it being illegal and dangerous, it's still a big problem in many parts of the world, including several countries in Southeast Asia and Sri Lanka. And in Tanzania is the only country in East Africa where this occurs. The force of the explosion kills everything in its wake, including both target and non-target species with little and young juvenile, and it can also damage substrate, so it can shatter coral reefs and damage the seabed, and that in turn has big impacts on the general productivity of the entire system, and it can take decades for coral reefs to recover from extensive blasting activity. In Tanzania, the explosives come either from the mining industry or construction sector, or they're homemade by mixing kerosene and fertilizer together. It's estimated that exploding a 1.5-litre water bottle would kill everything in a radius of 2 to 5 meters from the blast. And I just want to show you a short video so that you can see what this activity actually looks like.
Illegal and destructive fishing practices are a global problem. Their impacts threaten environmental sustainability and livelihoods worldwide. Destructive fishing gears capture non-target species and juvenile fish and can damage aquatic habitats. Dynamite fishing, in particular, can have long-lasting effects for reefs, fish, and people.
So the map on the right shows the location of Tanzania. It's a few degrees below the south of the equator in the Western Indian Ocean and East Africa, and it's bordered in the north by Kenya and in the south by Mozambique. And in Tanzania, blast fishing has been conducted at least since the 1960s, so over a period of about 60 years. And it's been widespread and indiscriminate, conducted out in the open with no attempt to hide it at all. It's amazing that there's still any fish left, to be honest. But part of being able to address this issue is understanding the patterns and where it occurs and what is driving it. And there's a lot of anecdotal evidence on the number of blasts and the location of blasts from people who live along coast who are really interested to record this data. So there's previously, before 2014, there were figures like 100 blasts on a single day reported in Kilwa, or 8 to 9 blasts an hour in Mtwara, a peak of 25 per day near Dar. And those kind of figures are very, very useful, but they're quite anecdotal. And they give a hint of the scale of the problem, but that kind of fairly unquantified data is not the kind of data that is very persuasive for communicating with decision makers. So since 2015, there have been 3 different scientific studies that have been conducted that generated quantitative data on the occurrence of blast fishing in Tanzania. And they are each allowed either the spatial comparison of blasting across the country or for detection of trends over time, or both of those things. And I'm going to summarize each of these one by one. The first one and the last one are both studies that I led, and the one in the middle is on this list is one that was led by another group that I'm reporting on their data. So the first study I want to discuss is a survey that was conducted in 2015 that used a towed hydrophone array to document blast fishing along the entire coast of Tanzania. In fact, this was a cetacean survey that included the hydrophone to detect whales and dolphins. But when it came time to analyse the data analysis was led by Anya Wittich and a team from St Andrews. She found 3 times more the number of dynamite blasts than cetacean detections. And we realised that inadvertently, apart from doing a national survey of cetaceans, we'd actually also done a national survey of dynamite fishing. So the map on the right shows Tanzania. There's 3 major islands. In the north is Pemba, then in the middle is Zanzibar, and then further south is Mafia. And Dar es Salaam is the main city. I don't know if you can see my pointer here in the middle, which is a major port. And the black lines show the survey track of the boat. We did a sawtooth pattern from south, right near Mozambique, all the way up to the Kenya border. And we did nearly 2,700 kilometers of track line. And during that time recorded 318 dynamite fishing blasts. And we recorded blasts from the entire coast of the country. But if you see to the right of the map are the blue bars, those are a number of blasts detected standardized by effort in each half degree of latitude. And although there's blasting everywhere, clearly Dar es Salaam, that long blue bar in the middle, is by far the area most affected. And in fact, near Dar es Salaam, we recorded in the region of 10 blasts per hour and 70 blasts per day. And around just over 60% of everything that we detected was within 80 kilometers of Dar es Salaam. And so this kind of national view allowed us to pick out the main hotspots. And I just want to play you a recording of one of the blasts. And you notice that it's a very sharp crack, followed by numerous echoes as the sound bounces off the surface and the bottom. So we looked for patterns in the data, and the top left graph shows the number of blasts recorded in each hour block of the day. And it was around 70% of all blasts were in the morning time between about 8 and 1. And then because we had 2 hydrophones in our array, we could get potential bearings to the origin of the blast. And the two maps on the right-hand side show close-ups of in the north. The top figure is Pemba, and the bottom figure is Dar es Salaam. And you can see that each of those dots are the location that the boat was when we heard the blast. And we coded them according to amplitude, so that the dark red ones were very loud blasts that we assume were close to the boat. And the very light pink blasts were very quiet and presumably quite far away. And so especially in the bottom figure, I don't know how easily you can see it, but I'm going to remove myself. You notice that the loudest blasts were all along the coast, and the further offshore you get, the quieter they were, and the bearing lines were all angled towards the shore. And similarly in Pemba, most of the loud blasts were along the Tanga coast, and the potential angle showing where they occurred was also on the near shore area. And so we assume from this what was already suspected, which is that most of the blasting occurs in the shallow near shore zone, but that we were able to hear the blasts up to 30 kilometers away. This survey was significant because it was really the first scientific study to document the spatial extent of blasting across the entire country, and the first comprehensive scientific data showing the magnitude of the issue. And because it was a scientific study, it was hard to dismiss as being unrepresentative or biased. And I think probably independently, around the same time, there was a lot of international focus from the media and journalists on blast fishing in Tanzania. There was a National Geographic article and a short film, and a lot of newspaper articles on the subject for the next couple of years. So moving on to the second study, in 2016, the Tanzanian Blast Monitoring Network was set up. It was a consortium of NGOs working on marine issues in Tanzania, included Sea-Sense, Mwambao Coastal Community Network, WWF Tanzania, and Sound Ocean Limited. That is Jason Rubin's organization. And working together, this group deployed land-based human observers to listen for blasts at 24 different locations along the Tanzanian coast, including 13 of the 16 total coastal districts. So very good spatial coverage. And those land-based recorders were out recording for nearly 2.5 years, from May 2016 until the end of 2018. And each recorder was asked to stand on the beach for a certain number of hours a day on certain days of the week and listen for blasts. Generally, you don't see them, but the sound travels much further. And so they're easier to hear than they are to see. And they estimate that they could hear blasts from 2 to 3 kilometers away, depending upon the weather. So they're monitoring a much smaller area than underwater acoustics, but it's still an acoustic survey of some sort. A phone app was developed, so each recorder had a smartphone with a phone app, and they would log their blasts on the app, and the data would be automatically transferred to and displayed on this website that you can see here. And there's a really nice interactive data portal where you can search for data according to a number of different criteria, including the district and the year, and whether or not the blasting was some people blast from on foot from shore. So if it was a foot fisher or a fisherman in a motorboat or a fisherman in an oar-powered boat. And the idea was that this data would be available very quickly after being detected and would be available for the enforcement agencies to access. So based upon those 24 sites, the number of blasts per year were extrapolated and there was an estimate that in 2016, there were close to 42,000 blasts across all those locations. A huge number. In 2017, this dropped down to under 10,000 blasts in the same area. And then by 2018, there was a huge reduction, and there were only 465 blasts estimated, and there were no blasts at all documented during the final 4 months of the year. And they estimate that there was a 90% reduction in blast fishing during that period. So as I said before, up until this point, the fishers really had absolutely no concern about being apprehended or prosecuted, and blast fishing happened openly, and there were really no consequences and no concerns of being arrested. But things started to shift in 2015. The government established the MAT, Multi-Agency Task Team on Environmental Crime, which was a group composed of numerous different parts of the government, including the police and the Department of Fisheries. And combating this is very complex. Clearly, it's a security issue as well as a fisheries issue, and not something that the Department of Fisheries would have the capacity to be able to address alone. And so establishment of the MAT was very important in that it brought together a lot of different players to try to solve this problem. And clearly it's not a good thing to have a lot of people wandering around the coastal zone with explosives. Financial support for the MAT was provided through an EU fisheries program, and at that time there was both EU funding and World Bank funding for fisheries development in Tanzania. Then a year later, in 2016, the Tanzanian President Magufuli announced a zero tolerance policy on blast fishing. And following on from that, for the following year or two, there were active interventions led by the Navy up and down the coast, targeting illegal fishers and fishing communities. And so that's the driving force behind this documented decline. So moving on now to the third acoustic study, which is one that we started in summer 2018, when blast fishing was already at really, really low levels. And in fact, the assumption in most places was that blast fishing had stopped and was no longer a problem. So we set out to put static acoustic recorders in the sea in areas that we knew were previous hotspots, where it was most likely to come back and begin again. And so the overall goal was to monitor the situation, because we expect it to return, as that's what's happened in the past, but to also take it to the next level, and this time to use more advanced devices that would allow us to actually locate the places where the blast explosions were actually happening, so that enforcement could be targeted in those areas. So on the map on the left, you see the red dots. We had 2 recorders in the north of the country and 2 in the south. Although there's 3 dots down there at the bottom, we only ever had 2 recorders down there at any one time. So 2 in Tanga and 2 in Dar es Salaam. And we had 3 hydrophones mounted on a triangular frame, as you can see in the picture. And the idea was that this would allow us to get accurate bearings to the origin of the sound, and that if we had 2 of those units deployed close to one another, that we would be able to locate the precise place that the blast occurred by intersecting or triangulating off both those units. So we made a triangular metal frame, which was 1 meter by 1 meter by 1 meter. And these were sunk to areas between 20 and 25 meters in depth, so they were diveable to recover the devices. They were secured to the sea floor by concrete-filled jerry cans, so about 150 kilos of concrete. And you can see in the bottom pictures that on each tip of the triangular frame was a separate hydrophone, and they were a known distance apart from each other, so we could look at the time of arrival difference of the sound on each hydrophone. And they were on a 50% duty cycle, and in Tanzania typically our sound traps the memory seems to fill up almost always after about 50 days. So this, we still have recorders in the sea, but we've analysed the first year of data, so from summer 2018 to summer 2019. And the majority of this, the analysis was led by Jamie McCauley, and I'm hoping that he's online. So if you have any specific questions about this part of the work, then he will be there to answer them, I hope. So we used a fairly simple automated detector in PAMGuard, and it had a fairly high false positive rate. So it detected the vast majority of bomb blasts, but it also detected a great number of other sounds. Jamie produced this program, SoundSort, to speed up the processing of the generated clips. So it allowed the clips to be visually sorted and listened and then confirmed by listening to all the potential blasts in each deployment. And this figure on the bottom left is all of the confirmed blasts from one deployment near Maziwe Island. And I just wanted to play you 2 more clips from that particular deployment, just to show the difference in the sound as, depending on how far away it is. So the first one is quite a distant blast. And the second one must have happened literally right over the top of our recorder. So looking at the data, we recorded 54 blasts during that first year. And so clearly, although everyone believed that blast fishing had stopped, a most significant result initially from our work is that it clearly continues in some places at low levels. The bottom left-hand graph shows the 4 recorders, so 2 in the north and 2 in the south. In the south, near Dar es Salaam, we only picked up 5 blasts in the whole year. And so it seems that that it really has largely stopped in that area, which was the former hotspot. But up in Tanga, there's one recorder at Maziwe near Pangani, where we continue to pick up moderate levels of blasts throughout the entire year. There was no real pattern in blasting over time. We continued to see the same pattern of most blasts happening in the morning. And we also managed to analyze the data by tide and by moon and came up with some interesting patterns that we'd not seen before. 2/3 of all blasts were during low or falling tide, and more than half of all the blasts we detected were during spring low tides, and almost none during neap tides. And we think that's, I mean, fishing activity anyway is greater normally during spring tides. And I think when the environment is already quite degraded, it makes sense that yields would be higher when more areas are accessible during extreme low tides. So the map on the left is the recorder that had the largest number of blasts reported near to Pangani. And the yellow lines are the bearings to or towards the origin of the sound. And the circular, the circle is 30 kilometers, which is roughly the distance that we think we can detect blasts. And so you see that there's a fairly consistent, it's fairly consistent that the majority of the blasts seem to be coming from the northeast of the recorder, not from the coast, which is the pattern that we saw before. And in fact, northeast in a sort of line parallel to the coast are offshore reefs, which are very shallow. And so we think that blasting is continuing on these offshore reefs that are about 15 kilometers from land. And also that happens to be inside Tanga Coelacanth Marine Park. And so it's the pattern of blasting in the nearshore area seems to have shifted, and either to avoid detection, or maybe they always blasted in these areas and they've simply stopped blasting in the nearshore areas. But now the only places where we still see the blasting happening is in places where it's much harder to detect it and where they're outside of the range of anybody on shore from seeing or hearing them. Then the graph on the right, I overlaid the data that you already saw from the blast monitoring network and the land-based recorders. So the bars in the blue are the 2.5 years of data recorded from land, and then the little orange bars overlaid are the acoustic detections. And the two studies only overlapped for 6 months, but had very similar results, and reinforce each other that blasting is still low. But interestingly, the acoustic recorders continue to detect blasts after the land-based recorders no longer were hearing any. And that's quite interesting. I mean, it makes sense to some degree in that the acoustic recorders, the fishermen don't know where they are, and they monitor a huge swath of the ocean, whatever the weather. Whereas these land-based recorders can only monitor near-shore waters. So I just wanted to compare and contrast these 3 different studies and the different acoustic methods that we have been used in Tanzania for documenting blast fishing. And they are each somewhat similar and complementary, but they have different strengths and weaknesses and different advantages and disadvantages that might make them better in different situations. So, for example, the towed array survey gave a really fantastic overview of the entire country in a fairly standardized way that really allowed for a spatial comparison and identification of the places where it's the biggest problem. The land-based human recorders is quite a different approach, which is quite flexible, fairly low cost, and the biggest advantage is that it generates data quickly. and allows detection of a blast and transmission of that information through to people who need to know very fast. And the static acoustic recorders are a useful tool because they can monitor such a huge part of the ocean from a single spot, and also allow for bearings and triangulation so that we know exactly which places the blasting occurred. And that allows for changes over time also to be detected. But on the downside, I think archival acoustic recorders, there's almost always going to be a delay between the recording of a blast and generation of the data and transmission of that data to the people that need to know about it. So that's one downside. Acoustic recorders are also quite expensive and prone to difficulty. But land-based recorders are also subject to biases which are quite difficult to quantify. They also monitor a very small part of the ocean in comparison to acoustic recorders. And unlike acoustic recorders, which fishermen don't know where they're located, land-based human recorders, it can be quite risky to be documenting illegal activities. So I think the key thing is that all of these different approaches provided quantitative data on this illegal activity. And although monitoring doesn't solve the problem, we're just documenting what's happening. I think in this instance, knowledge and data is power, and it did come with and improve our ability to communicate the problem and the scale of a problem in a way that I think spurred actions to combat it. So thank you very much. I have many people to thank. Many people have been involved with this work. It was funded by Code for Africa, and I'm happy to take questions.